Hey mathematicians, welcome to day 2 of our work with rates. Using your work from Tuesday, where I was super psyched to see you all do a variety of activities to get your data down. We're going to use those rate tables today to make some observations about your data and make some predictions moving forward. So to kick things off here, I'm going to go back to the data table that I made yesterday and that I shared with you. We talked about this, how that I wasn't necessarily trying to be consistent. I was just bouncing it. And I know that a lot of you, when you did your experiments or your data collection, you too were coming up with these inconsistent rates. It makes it really hard to make a prediction about what might happen, but it certainly can make an observation. And we talked about different reasons for why I might have had 9 in the first 10 seconds, and then I was up to 21. So what I want you to do is I want you to be thinking about adding a third column in your data tables. You can use the same data tables, and I want you to be adding a third row. Whereas for the first 10 seconds, it was +9 from no bounces. And then in the second 10 seconds, when I had a cumulative of 21, we noticed that I would add 1 to get to 10, and then I would add an 11 to get to 21. So that's actually a change of 12. Then from 21 to 28 is a change of 7. We said that something must have happened there, dropped it or something like that. Then between the next two, from 28 to 39, you're going to notice that again, you add 2 to get to 30, and then +9 is 11. And then I was really grooving here. I went from 39 to 53. So that was really a big jump. So what I want you to be thinking is about adding that third column so that you can have an observation about your data. Here's an example of a 6th grade data table that one of your mathematician friends put into their assignment the other day, and you'll notice where they've got that third row here. So that's what I'm looking for you to be able to make that observation, is what is the change that happened? And then you're going to notice that this person, as a lot of you are going to find, that their rates were close, but they were not a consistent rate. And that's totally fine. We're not going to be judging anybody here, but it's just a matter of making an observation about your different activities and how did the rate change over the course of that time. So here's an example of what I want you to do with your rate tables by adding that third column. As you make those third columns, I'm going to ask you to answer some questions underneath those tables. Why was there a difference in your rates, do you think? What might have been happening as you were doing your test? And what would this mean for making predictions about longer rates of time? So I had you go for 60 seconds, but the idea of doing these rate tables and then in the future we'll be making equations from them is to make accurate predictions or accurate mathematical calculations about what the number of your activity will be for amounts of time that you don't want to test. I'm going to show you an example of that on the other slide. Now here's an example of a data table that again came from a student, and you're going to see very accurate recording here of the 10 seconds, the 20, all the way up through a minute, like I had asked people to do. Everyone's going to be adding that third column where you're going to be able to see the amount of change that happens, and you're going to notice this person was off to a start with a very consistent rate of a change of 18. What I want you to be thinking about for the next step is they challenge themselves to push this, and I don't think they did this for an hour, but they challenge themselves to think, well, if I know what 1 minute is, well then what's 1 hour? And that would be 60 minutes in an hour, so that's a times 60 activity. You look over here on this side, what you do to one side of the table, you've got to do to the other, and in fact 102 times 60 is in fact 6,120 bounces of a ball. And I know that the person didn't do it for an hour, but that's a very easy way to use these data tables to make jumps to longer amounts of time. You could make a jump to 2 hours. You could combine 1 hour, and you could combine 30 seconds. And now all of this is well and good if you have a consistent rate. Does this person have a consistent rate? Not so much, nor did they have to, but that's a conversation for a little bit later. What I want you to do is try to extend your table so that you can use some calculations to go from your minute to longer amounts of time. All right, so to wrap things up here, I'm going to go back to my data table, and I'm going to notice now, though, that I don't have that third column that I want you to do. I took that off on purpose, but you do notice that I added the axes for a graph here. And if you think back to the winter survival unit that we did, and when we were graphing all of that weather data, we were following trends over time with line graphs. So what I'm going to ask you to think about is, if you were thinking about graphing this, what would the slope of your line be? Or what would your line look like? Is it going to be a diagonal like that? And what would that indicate? Might it be something that starts like this and then shifts and then goes again? What might cause that? Or is it something that would be like this and then go up quickly? Think about what might determine the slope of your line and make some educated guesses about that.